We are the team of Professor O and start presenting quiz now. Our team carried out the project under the theme of SLAM, improved by predicting odometry for disaster situation. The table of contents is as follows. Many incidents and accidents often cause buildings to collapse. In some cases, rescuers may lose their lives or get injured while trying to rescue people trapped inside buildings. Or there are cases where rescuers can't enter directly because blocked by something. To solve these problems, we aimed to attach the VLP-16 LiDAR sensor to unmanned air vehicles such as drones and quadrupedal robots to safely explore and map places that humans cannot explore themselves. Let me tell you about the LiDAR sensor our team used. LiDAR VLP-16 has a radius of 4.4 cm and 16 channels. Its error rate is about ±3 cm. The vertical measurement angle of 30 degrees is measured with a resolution of 2 degrees per channel, and the horizontal resolution is 0.1 to 0.4 degrees. It can be measured at a speed of 5 to 20 Hz, and the wavelength used is 903 nanometer. The robot operating system develops an application program in robotics. As a software platform to do so, implement the necessary function in program development such as SLAM, which we will talk about later. The reason for choosing RS is that it can be developed and executed in various languages, not in a specific language, and consists of small nodes, so it can be easily expanded even if the amount of data increases or the format changes. However, there is a problem that we have to match the OS version, so our team proceeded with Ubuntu 8.4 and Lost Melodic to match the desired function and specification. SLAM is a technology that simultaneously tracks the location and maps the surrounding environment. The picture on the left is a schematic of the algorithm. After finding similar parts with data from each scene scanned by the sensor, it determines whether certain data have feature points such as edges, curves, and flat surface. And if it is present, it creates a coordinate transformation matrix and applies it to matching. There are online SLAM and offline SLAM methods in SLAM. Our team used online SLAM. And LOM is a model of SLAM that uses LiDAR. It is a model that increases the mapping accuracy of SLAM by estimating LiDAR's odometry. Estimates the odometry by the 6 DOF information obtained from LiDAR and the values between each PCD. The picture below will complete the map by correcting the distortion of the PCD obtained by LiDAR through the odometry estimate. In order to map directly using a LiDAR sensor, we prepared measuring equipment using a laptop, a portable power supply, a LiDAR sensor, and a moving cart to maintaining horizontality. The picture on the right is a node graph that can visualize the process of running when ROS. This is a picture of Gwangwon University Chanbit basement using LiDAR. Compared to the first basement floor on the left Chanbit one, you can check the VCD with a high resolution. If you look at the picture on the left, you can find the yellow edge point and the red planet point by calculating the distance between any one point and the other point in the PCD in one scanned frame. This is the process of identifying feature points for scene matching and odometry. Looking at the graph on the right node, it can be seen that the row sharp point, less sharp point, the planar point, less planar point are found to proceed to the odometry step. In the odometry algorithm, the distance between each feature point is obtained through the feature point value obtained in the multi-scan registration. And the odometry value is estimated through v-square weight using the value and the 6 DOF value measured in LiDAR. As shown in the picture on the right, 1 and 2 and 3 DOF represent forward and backward, left and right, up and down movement, and 4, 5, 6 DOF represents the forward and right slope and the degree of freedom of rotation. The graph on the left is shown that based on the case frame of the path robot traveled. A point is called PK, and a set of all data collected while taking one frame is called PK bar. Points farther than the threshold were assigned a weight of 0. Continue to identify the current location while repeating this execution result and terminate the algorithm when the number of iterations meets the maximum or the current location converges without change. The blue line K represents the odometry up to case frame, and the black line QK represents all PCDs up to the case frame on the entire map. The orange line TK plus 1 and the green line QK plus 1 are displayed on the entire map. By matching the radar odometry information and PCD calculated in the K plus 1 frame with the previous values, respectively. In order to optimize PCD, it is necessary to find feature point and obtain the correspondence of feature points, such as the multi-scan registration method. At this time, in the process of obtaining edge and planar point, edge lines, and planar patches, it is obtained differently from multi-scan registration method. Looking at the ROM and SLAM block diagram under. The radar mapping proceeds in this way and output a partially matched value every 1 Hz, and the partially matched scene is finally mapped to the entire map every 10 Hz. Our team took a picture of the back and basement of Chanbikwan. This is result of mapping by carrying sensor directly. Overall, we are a team around the school to collect the map data. And finally, shown left picture is our result. During mapping, we are affected by radar speed and PCD frame speed. When the moving speed of the radar sensor is slow, there is a problem that feature points cannot be well identified and distortion occurs in the process of matching. And when working while moving fast to solve this problem, there is a problem that if you work too fast, there is a distortion occurs. So work at an appropriate speed, but distortion occurs in some paths. In addition, there was a problem that some distortion occurred on uphill and downhill load because the IMU sensor was not used. If the ROM and SLAM carried out in this project were improved a little more and object detection algorithm are added, rescue target will be found and rescued in real time. Using better technology can greatly help save lives by putting them into SQ and exploration robots. This is the text our team referred to while carrying out this project. Thank you.